Welcome back to Spiderweb Education. Today we are going to be talking about NAND gates. We're going to talk about the symbol, the truth table, the schematic that proves our truth table, and then a few more applications for a NAND gate. Alright, so let's start with the symbol. The symbol should look fairly familiar. It looks exactly like an AND gate, except it has the little round circle on the front of it. It has two inputs, A and B, and it has the output Y. Now if we look at the truth table has four different configurations, of course all being 0 or 1 binary, 0, 0, 0, 1, 1, 0, and 1, 1. Now let's look at the circuit and verify or come up with our outputs on our truth table. So if we look at the first one, if we ground the inputs A and B, we'll get current flow from power to the ground. That will make this point 0. If this point is 0, then our transistor will not turn on, and if our transistor is not turning on or not conducting, our output will be pulled high, and so that will give us a 1 on the output. If we then take A low and B high, because of this low, we're still going to be in the same situation where we're going to get current flow going this way. This will be low. This will not turn on, this will not conduct, and our output will again be tied high. So we will again be at a binary 1. Now it's going to be the same for the 1, 0, except for the ground would be on the input B. So once again we get a 1 on our output. But for a 1, 1 on our inputs, or a high and a high, that will give us a high at this node, which will then turn on our transistor. Our transistor will conduct, and if our transistor conducts, it takes and it pulls our output low. Therefore we get a 0 on our output. Now if we look a little bit closer at our truth table, we'll be able to tell that our outputs are inverted from the AND gate. Now this should make sense, because if we look up here, this is a NAND gate, or a not AND. The not AND means we are inverting. And if you look at this circuit, this was our inverting circuit. We're inverting our AND gate. Therefore, our outputs are going to be inverted. And that is what that symbol on the end of what looks like the AND gate is for. It means we're inverting our AND gate. Now, one more thing we need to talk about. A NAND gate is also known as the universal gate, meaning we can use it to create other gates. For example, if we put two together, two NAND gates, if we tie the inputs together here but still have an A and a B here, this is an AND gate. So for example, we don't have an AND gate to use in our circuit, but we have a whole bunch of NAND gates. We can tie two of them together this way and it will create an AND for us. We can also take a single NAND gate, tie the inputs together, so we just have an A, and that is going to be an inverse of our input, or that's going to be a NOT. Then one more, if we take two NAND gates and we tie the inputs together to where one is A and one is B, then we take those outputs and we feed them into one more NAND gate. This gives us an OR gate, where that's our two inputs and this is our output Y, but it's an OR. So if we don't have an AND, a NOT, or an OR in our cabinet of components, but we have a whole bunch of NAND gates, we can use that NAND gate to create other gates. That's why it's called the universal gate. Alright, so we've taken the NAND gate, we know what the symbol is, we have verified the truth table using the circuit, and like I mentioned, this is the AND, this is the inverter or the NOT gate, and we know that it can be used as a universal gate to make AND, NOTs, and ORs. Alright, if you have any comments, please leave them below for me, and as always, please subscribe to Spiderweb Education.